Hello and welcome to this modular in a week-ish kind of video, Arduino modular in a week, where I go through part of making a module. So in the last video I started making a Arduino based sample and hold circuit or module. I went through, I had ordered it, I've gotten the PCB and the panel, we have it here, and we did the internal noise source and did the sampling of that. Today I'd like to go through a few things that I've learned from doing this. There's a few things that I need to change, so we need to do another panel or another module, PCB, and also how we can solve the input signal issue, which was why I stopped the last time, and now I have a bit more information on that. A bit good and a bit bad. I don't know. We'll go through that. I'd like to say thank you to my Patreons who helped me by supporting me over on Patreon so I can make these videos. Thank you very much. You are awesome. And yeah, they get to see a bit more behind the scenes what I'm doing, and a bit sneak peeks of modules that or projects that might come to fruition. That you never know. I think they've seen a lot of projects where I've said I'm gonna do that someday, and that someday is not yet. So they know there's a lot in the pipeline, I guess, or a lot of things that is never going to see the light of day. So anyway, with that said, thank you again, and let's go through some of the things I've learned the last couple of weeks. Let's start by looking at the old schematics, because these are few of the things that I've learned. Two things that I really worked a lot with on this once I got the module was that the trig in on A6 didn't work as expected. I fixed that by just switching A6 to A3, just connecting these two together with a jumper cable. And then after that I didn't get track or sample switch to work on A7. And that one I didn't think of just trying to change port. But it eventually someone, I think it was Howl Monkey on my Discord server, found the information online that I somehow missed, that the input pull-up command on the Arduino works on all the analog ports except A7 and A6. So these two ports, that input pull-up doesn't work, so they are just analog read in that case. The other ones you can switch to be digital inputs or outputs instead. So that's a very good lesson, and something that I haven't heard before, but was very good to learn, because then I just switched this port as well down to one of these, A3 or A4, and that one worked as well. So in the new schematics I removed A7 completely, because that's not available on all the Arduino chips. So the Arduino Uno doesn't have A7, so because of that I leave that blank for now. I put the sample signal input on A6 and moved the track or sample switch down to A0, where the sample signal was before. I've added an internal external switch. I thought I could do that in software by just checking if there was something on the port, but realized that the port is, I thought I could just check if the port is grounded or plus 5 volts for a number of cycles, but it can be down there or up there for quite a long time, so then it would just switch over to internal instead of external by itself, and that didn't work. So I have a switch for that and added that to the panel. The trig LED was there. Trig input, we moved to A3. Max and min pots is still down here. So we added another switch for that. And then in the old schematics, I had this summing mixer here. And I didn't get any sound out. And it just turns out that these two resistors are probably too much. So the op-amp didn't amplify the signal. So I just removed the op-amp and it sounds better. So just leaving it out, it still sounds great. Shouldn't be a problem, I think. So let's hope I'm correct in that. I removed half the components over here. We don't need minus 12 volts. We don't use that in this circuit at all. So remove that and remove that op-amp. So now we just have this op-amp over here, still for the input, sample input. And the second one is down here, this circuit that Luther over on my Discord server suggested to use to bypass the signal when in track mode. So I don't have to route the signal through the Arduino, because as I'll show in a bit, that really distorts the signal. And here you can see that circuit in a simulation that Luther did as well. So here we see that when the pin is low, this signal coming here goes out and to the output. When we put the pin high, it changes and we get this signal through. And this is by using one transistor there and two transistors here to decide which one connects to ground, up here or down here. And this one inverts this signal. So that's basically it. I had to be able to accommodate these extra components, I had to make it 5 millimeters wider, so it's now 30 millimeters. It's still quite packed in here, even though we have some room, for example, over here. But yeah, it's packed. The panel looks like this. Instead, we added the internal external switch down here. We have the track and sample switch over here. Still sample input, max and min value. We have this hold, which I see now is very not in the middle. Not that one either. Have to fix that. I also removed the clip because I also realized that the clip is basically like when listening to the noise, it's basically clipping all the time, and very many times also when you listen to the input signal. And as soon as you change the max and min values, this one stops clipping or lighting up. So it really, either it does too much or it does too little. So just decided to skip that one and have some room for this other switch instead. So gonna fix this. That doesn't look too good. But other than that, it's ready to order again to improve on the design and get these new functions ready. So let's look at the code and how it handles now. A few pins have changed. This is just according to the schematics, or these might change when I get the new PCB. The variables are, I've added the internal or external pin and the int or x, the variable that we use to check if we should listen to the internal or external. The setup, just added a few more pins, and so this is the code. To minimize, because we have 3 pots we want to read and to check the values of, to because I ended the last video with that I had trouble getting a nice input signal, which I thought I could solve with code, but the analog read is, if you want to have 10 bits input, then the analog read is the fastest way you can do it. You can read faster on an input, but then the resolution minimizes or goes down to 255 or 8 bits, and then you can read it really fast. But at 10 bits resolution, analog read is as fast as it can get, as far as I've read online. So instead, I only read the low cut and high cut knobs once every 50 times. Just a rudimentary way of doing this. You can do this with timers and set it to milliseconds and stuff like that. This is easy enough just to have a timer to read this. I don't think that takes too much energy from or CPU power from the MCU. And then also, I also read the enter X pin once every 50 turns. I don't need to read this all the time. It's not that critical, and I think this is we're talking milliseconds here, so really not that big a deal. And then we read the enter X. So depending if we read the external signal, the sample will be a map between 0 and 1024 of the input to the low cut and high cut values of the analog read of the signal input. If it's the internal, we don't check the analog read at all, so the sample signal would then get much better here as well. So, and the sample is just a random as before, low cut, high cut. Then we check the trig in, if there's a digital, we do a digital read to see if there's a trig. If there is, we write the trig LED high, we send the sample and then we do the while loop and do nothing while the trig is low. And then if there's no trig, so now we've added also, if digital read, sample or track pin is low, then here we send the sample again. And this one is just reading all the time over here, and down here we just send it out if we are in track mode. If we're in sample mode, we do nothing. And this is basically the whole program. So it's not more difficult than this to make a sample and hold with Arduino, code-wise. So the first prototype, you always have to budge quite a bit. So here's a few things we've added. But let me show you some of the features of this one and what happens when you mess around with this. So first of all, we have output here and goes into the braids. This one with the what the F man that I call this sound. It's wavetable FM, I think. So we are now in track mode and we're using the internal signal. So this is the switch for that. So basically we just have noise going out into the oscillator. If we add, so now we're holding the signal and tracking it. So when we're not holding it, we're tracking it. If we're going to sample and hold, we have normal sample and hold as we had before. And we can do this so it just stays there. And this also affects the noise signal out. We can, if we want to, we can use this as a noise source, either tracked or, let's see, just like this. So in track mode, no hold signal. It is a noise module that, and these, as we said before, don't do anything much in that configuration. But again, here, and of course what we've added is the external signal. So if we go into external instead, and now we are just passing it through, reading the analog signal. We're not using this little extra circuit that I talked about before, because that is not implemented here. And as you will see, it might not be needed. It kind of depends, and it's kind of cool without it. So here we just have the Y output from the marbles, which is just a random voltage. And as soon as it goes red there, that means it goes negative, and then this one just doesn't work. But listen what happens when we start to twiddle with the min and max values. And when we go over here, and we can of course just invert it by doing that, but so really cool that when you reverse these, so the slope will just it will inverse the slope, but as it goes down it will, it does something that you do these little twirls and twiddles that I really think are really cool. So I like that. That's a nice feature that I didn't know about, that I now know. Of course we can have the hold, and now it glides in the track, and this is what, like, so you have still the slope of the CV signal, but holding. And if we instead do sample, we get the more stepped thing, and in the track the thing there. So that's it. Now the reason that I wanted to have the bypass circuit was because then I could work with audio signals, because there is this one thing. So if we take the seesaw oscillator here, the braids with the seesaw, and put that on the input, so now we can use this one to control that one, but also just to show you how the signal sounds like. So let me show you the original signal. Sounds like this. It's quantized. There, okay. And if we take it through this one, it's a little bit more dirty in the signal. Down here it doesn't matter, because here it's down in LFO mode and the analog read can keep up. But up here it's kind of dirty. But again, and then you can use this as a wave folder shaper, but it's not what it's built to do. So maybe I shouldn't focus too much on that and instead focus on all the cool things it can do when it does what it's supposed to do, which is sample and hold CV signals and or noise. So the extra things you get out of it is just cool stuff, I guess. So So another short video just showing you a bit of the process is in trying to figure out how to do this module, some of the findings with the Arduino and the code, and also how much I've figured out that you can actually do with this. And I think I'm going to, when I order the PCB to try the next version of this, I am actually going to not add that bypass circuit that I thought about, but which is nice to have in itself, especially if you want to have audio signals. But I still think there's the thing that you can change the audio signal with the max and min potentiometers is in itself really interesting. And as long as you don't want to listen to the output the audio signal, if you want to run that through, to use an audio signal as a control signal for something else, that is possible. But again, you can't, the audio signal won't be as nice when it comes out. But I can live with that because all the other functions of this module is really cool as it is right now. So yeah, hope to get back to you soon with a video of the next iteration of this one. So until then, take care. Bye.